There we go. Sorry about that. So we're looking at using the debugger for Python, which you can use. I think it will work equally well with JavaScript. Don't quote me on that. And certainly you can use this anytime you're writing code. You don't just have to use it for recursive algorithms. So with the debugger, what we do is we set what's called breakpoints. And that is, I click, just to the left of this line of code here. And now I have this red dot, that's a breakpoint. And what the debugger does is I can control the Python runtime going through my program step by step. I can move it forward, I can move it backward, I can have it skip things, and breakpoints tell the program, if I just run it all the way through, where to stop. So I'm just going to throw a bunch in here. Where the Alice stuff we can ignore. We don't need to worry about that. In fact, let me comment that out because I don't even want that to run. I don't want. And in fact, I think I'll just comment all that out. So I've got a bunch of breakpoints here. And now let's see what happens when I run this. So a couple things happen. Note that it just kind of knew how to run my program. It popped up the terminal over here, with which I'll just sort of leave off there to the side. Note that I've got local and global variables. The global variables, there's not a lot that's interesting for us here. There's a lot of it, I guess. If you want to get under the hood of Python to see how it knows things, there's some interesting things to see in the global variables here. Like it's added a name, dunder main, but that's a special variable. Function variables, you can see that indeed Python has gone through, excuse me, and it's seen, hey, this is the function that we're running. I need to store that function somewhere. So it's created some function variables in the global scope, but we're more interested in the local scope inside this particular function call. And so the debugger stops wherever I set a breakpoint, and then I can hit continue, where the program will just keep running till it hits the next breakpoint. I can hit step over, which I believe skips, it won't go inside this if statement. I always get a little confused about that one, to be honest. Step it into, if I had a function that was being called here, I could go into that. This kind of moves me out of this. I can hit restart. I can hit stop. What I find easiest, to be honest, is I set a whole bunch of breakpoints and then I just keep hitting continue. So we skip this if statement, right? Because 5 is not equal to 1. We get to this return statement, and you can see we've got a call stack here. And here is where the program started. Here was the first function call, factorial of 5. And now we're about to recurse. And now we've got a second call stack. And here n is 4. And this is kind of cool. I can click to move back and forth. And for that first function call, I can see, hey, when I called factorial with n equal to 5, right? Because that value of n is local to the scope of this function call. It's still waiting. It's waiting, Clarice, you were saying, well, what is happening with return here? Return is waiting for all this stuff to get resolved. It knows n, and in fact, if I hover, it'll tell me, but it has no idea what this is, right? And so it's waiting for this to be resolved and for that function call to return something. And here with 4, I use the debugger again. Oh, I hit the wrong button. Thank you, VS Code. I hit move forward. And again, we see it hits the breakpoint, right? N is 4 here, and we're about to recurse again. And we've got our third call stack here, or our third function call on the call stack. So this is kind of cool, and you can see kind of how this works, and we can just keep stepping through this. And as I'm doing this, let me pause actually and see if people have any questions or things that you're curious about. I do not use the debugger a ton. Some people really like it. I usually find print statements easier for my own debugging. I do think it can be a great tool to really understand what your program is doing. To be honest, even with object-oriented programming, when we get into Django, it might start to get a little trickier because there's going to be all this stuff. But for the stuff this week, like, and also just for getting comfortable to understand like how the computer works and like how programs are actually executed, like running some simple programs through the debugger is not the worst idea. So again, we've got our call stack, right? All these different function calls, and is 5, 4, 3, 2. They're all waiting. This one's waiting on this one, which is waiting on this one, which is waiting on this one, right? Think about all those nested parentheses. When I was drawing out the sort of like 5 factorial, like n minus 1s and so on and stuff. And now we're getting somewhere interesting. In fact, I'll add a breakpoint here so it doesn't just jump all the way through. So you can see we are inside the loop now because we finally have got an n down to 1. We're about to print base case returning and return 1, and then all this stuff is going to get wrapped up. And let's see what happens. So unfortunately, we can't quite watch it get wrapped up. I'm not skilled enough with the debugger to know how to do that. But basically, as soon as it figured out one, it could figure out, the value for each of those stack calls, and everything just returned. And then it was able to like figure out values and return them. So I just wanted to intro the debugger and demo using it a little bit here. And I'm curious like what questions people have, if there's anything people would like me to go over again. And also if this was helpful or if this just kind of added a little extra confusion. Cool. So let's talk briefly about assignments, and then let's look at one. And I'm just going to look at our schedule. I don't think we have anything else on the calendar today. Those of you working on retests, I believe those are due on Monday. So you may want to take an hour out of your day at some point today to work on that. It is important to spend some time with this stuff. I don't want people to abandon recursion entirely. However, there's value in working on the retest as well. So in terms of assignments, and then we'll tackle one of these in a minute, Anthony, and we'll see another one. First, we want you to implement a simple loop in recursion that just counts from like 0 to 10. Then I do want you to put that program into that Python tutor. I want you to visualize the program that you wrote and step through it. After that, we do have a number of recursion challenges, and I think what we'll do is tackle one of these now. There's a little bit of reading here, which is worth doing, but really, we want you to practice implementing a lot of these previous problems that you've done using recursion. And in fact, you've seen me do the factorial. So I would just recommend, I'll make sure to push this code. I would recommend, feel more than free to use my code as a guide code, but don't copy and paste, actually type it out. And because for me at least, that's, as I'm doing that, it kind of forces me to think about what the program is doing and try running it in the debugger. Again, I don't use the debugger a ton. It is a useful way to kind of get more insight into like what the computer is doing. So this might take a while because, we've got palindrome, 99 problems, and Roman numerals to implement recursively. And after that, we have a couple sort of guided tutorials. And it's probably worth going through these, at least one, and coding along with it to see how it goes. I would do that. We might look at one of these in a minute, but I'm actually probably going to grab one of the challenge problems. And then there are some stretch assignments here that involve just like more challenging tasks that also, like with binary search, touch a bit on things we haven't seen using recursion. And then there's a couple other stretch suggestions here to try using recursion for. It is also interesting to think about like the big O, the runtime complexity of recursive algorithms. I think most of the ones we'll see from these recursive challenges will be pretty straightforward. It's really in these stretch ones where you might see something interesting. So I would say this recursive loop stuff and the recursive challenges here are sort of like the core to focus on. And after that, you know, like if you have the assessment to retest, that might make sense to work on for a bit. Otherwise, there's stuff here to dive into. So I think what I want to do is, why don't we do one of these problems recursively? How does that sound? Which one do people want to do?
Roman numerals.
Okay. Let's do it. That is maybe the trickiest one.
Exactly.
Yeah. Yeah. Okay. I'm fine. I'm fine with that. We may not get to 100% of a solution. Um, let's go for it. By the way, if you hit /, you can search through a repo or an org, which is great. Excuse me. And I'm just going to go ahead and clone this. Let's do some Roman numerals. And does this sound good to everyone else as a problem to tackle? Yeah, is it? Are we mostly yeses here? Okay, awesome. We put this back on the bottom. And of course, I need to figure out how to do this. That's we'll do it like this. So what I'm gonna do is copy everything from that Roman numerals directory because it has like tests and stuff into the what was it? Pictures, demos, and notes. And of course, if I'm copying a directory, I need -r. Maybe we need to make the directory, and now let's see if that works. Okay, awesome. So now let's go into that directory. Awesome. I've got all the stuff I want here. I'm just going to open another VS Code window here so that like the editor is here and all that good stuff. And now we can write code. So with recursive algorithms, we always want a base case and that recursive case, and we probably need to figure out the base case first. I'm not gonna worry. Yeah, so I am just going to comment out all these other tests. And in fact, if I run that now, that should indeed fail. So I'm just going to worry about like a single Roman numeral and get that working. Let's see, VS Code has a nice sort of preview feature we can look at here. So I need to refresh myself on this problem a bit. So we're giving some hints here, write a method like toRoman, takes in the input number, so on and so forth, create an output string, create a Roman numeral to Arabic map, iterate over the map, da 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 da, even divisible times, blah 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 blah, blah blah blah. I'm gonna honestly ignore that for now because I'm getting a little confused there. So this is a good start, right? I've got this, I've got this. I can kind of figure these out. I am honestly not sure how far we'll get with this one, but we certainly can try. That said, not going to do all the work for you guys, but we probably need some sort of dictionary, right? We still are going to need that. And this is, I do apologize that I'm using like a lot of, well, I'm trying to use some editor tricks here, but they don't seem to be working. There we go. Normally I wouldn't do this stuff, but in the interests of time. And now we just need commas. And now this stuff just needs to be properly indented. And let's see what that test looks like. Assert to Roman 1. I. So I kind of goofed here, didn't I? Because I got this backwards. I really need Arabic to Roman. To pass that first. Yeah, yeah, we're passing in like the Arabic number, and then we want to get the Roman numeral. So I totally goofed here. I'll just no, we'll just name it that. I'll just leave that there because it's already there. And we'll just have to do this again. Um,
Could you do if the Arabic number equals the value, then print the key?
Say that again.
If the number that you input equals the value in the dictionary, then you print the key.
Yes, like if we add one, we should print I, do you mean?
Yeah, I was just saying instead of like switching everything around.
Um, oh, like if Arabic num equals that, we could, but then I guess I could do like a for in, like searching through values. I honestly, and I guess Python does do that. I honestly don't think about dictionaries that way because, sort of like the way they're meant to be used is you want to know what the key is and then look up that key. Um, but there probably is a way to do that. That said, it also adds like complexity to the logic, to understanding what the program is doing. Um, and there's undoubtedly probably better ways to do this, in part because of the interest of time. I'm just sort of going with like what I'm familiar with. I want to get through this bit as quickly as possible so we have something running so we can start trying out some recursive stuff.
Question on the keys. Is it just better to have the keys as a string rather than a number?
That is a good question. We may run into an issue there with depending. I'm a little more used to JavaScript. I may have to do a little parsing. That is a good point. I'm not even sure if Python lets us use. Um, does Python let us use numbers as key values?
Yeah, I
Or
learned that from the
Yep.
test. They definitely do, but I
awesome.
don't think it acts the same way.
Well, let's see how it works. Because that would make life easier, because you're right, we probably are getting numbers passed in if I look at this test. So let's do return Arabic to Roman sub. No. So now this should at least pass our first test. Unless, of course, which is very possible that I've gotten an error. And indeed, it does not like something here. And I am getting a key error. So I'm not sure what the deal is there. If I kind of run the Python REPL and make a little dictionary, just say like my dict equals that, my dict sub 3. So that does seem to work. Let's see what we have wrong here. Assert to Roman, one is I suppose what I should really do is Google. I don't actually know what like a key error means in Python.
So you're missing the key error 4 as the IV.
Say that again.
You're missing the number 4. You don't
Oh,
have number, yeah, you don't have number 4 in.
oh, I meant to comment that out too. Thank you so much. So just goes to show I did not read this carefully enough to see where my error was coming from, because the failures, in fact, it tells me right here at the top of the test message. So if I read that a little more carefully, I would have gotten there right away. So Fu, thank you so much. And just goes to show that it always pays to take a little more time and be patient in reading error messages. So let's run PyTest with test Roman numerals. And so now that works, just for one. And now let's uncomment 3 and see if that one works. And that one totally fails. And so now it might start to get a little interesting, right? And I think that we've got special cases, and so on. So now maybe it's time to start thinking about recursion. Because we have to think about like an input of 3, right? So first off, I need to turn, can someone remind me if I've got a number, how do I basically like turn that into let's see. Okay, so oh no, we don't have to worry about turning a number into a list yet. I actually could use a little help. Someone remind me, what was like one of the solutions for this, not recursively? Like, how would we turn one, like, what's the not recursive solution to solving this test here? How did
We did like remainder divides, but we started from the biggest value first, and then we worked our way down. So you check to see if 1,000 can go into it, and then you concatenate that value to your answer, and then you work your way down with the remainder after dividing or subtracting.
Got it. Right. And makes that makes sense because we do kind of have to get rid of the biggest ones first. Because otherwise it becomes very difficult to figure stuff out. Like how do I build this up? Because if I have like CMXL 4 or whatever, or 5, like 900, I'm not expressing it well, but think that reminder helps me a lot, and that makes sense to me that we do kind of have to start with the biggest stuff and work backwards. So I may have to do a little refactoring here, and in fact I may end up like re-implementing this, and then if we have time we get to the recursive solution. So I do apologize, but as long as we're doing this, it probably just seeing my workflow is helpful, even if we don't get to that much recursive stuff. So I do totally have to like refactor what I've done here. And Cody, I think you're right. We really do want like an ordered list of our Roman numerals. So I'm not going to get rid of this stuff yet because that would break my code, but I will do like ordered, like, let's just call them numerals. There's probably a better word here, but I'm not sure what it is. And we'll just use like R for Roman. And we'll use A for Arabic. Let's see, I think I can.
You might just want the keys for the list. Just if you want like an order to put to order your list, you might only want the keys starting with 1,000. I think that's what we did last time. Somebody help me out.
When I demoed it, I had like a separate list of the ordered numerals for each, like from the highest value to the lowest.
Yeah, I think I'm gonna kind of go with what I know here again. And then this should be 1,000. And I have a couple of things to get rid of here to clean this up, but. So does this look right to everyone? M is 1,000, R is 500, C is 100, L is 50. And let's see what, and this of course needs to become a list. Thousand, 150, 550, 10, 5, 1. Okay.
So you might want to switch the 500 and 100.
Oh yeah, thank you so much. Thank you, Clarice. That ought to do it. So we've got Arabic, we've got Roman. I'm not using this anymore. We'll get to the special characters when we get there. And now we actually have to do something with this. So we need to go through this in an ordered fashion. So for num in ordered numerals. And we need to, what was the process again? We basically need to do division, like if num dot a modulo Arabic num I'm just used to kind of like having like lists of like my data, kind of like this, because this way I just have it all right there for whatever I want to do with it. So this is honestly, I may have bitten off a little more than I can chew here, but let's see how far we can get. And if we get to like getting enough down to then implement it recursively. So someone give me a hand and kind of walk me through, now that I've got my data a bit more organized, what's the logic that I want again here for like going through biggest to least and with modulo and stuff?
You want your
I think it
modulus.
should also be A.
Say that
Oh.
again.
I was just going to say, I think it needs to be A instead of the R, right?
Yes, thank you. Yeah, A is for Arabic. And that needs to be R right there. And what were you going to say, Cody?
Your modulus value is going to be a number of the number of characters, Roman characters that you're concatenating to the answer.
Got it. Thank you. Okay, so let's see here. So in fact, this return statement we don't need anymore. Let's see if this runs. Let's see if this runs. I'm gonna re-comment this test out. Let's see if this runs just with one. So I just want to get my typos fixed now that I've like totally refactored how this works. So right. Okay, this obviously isn't gonna work.
I have a question.
Yeah.
And linked in the article is the divide and conquer strategy. Could you like make recursive functions for each character and like return the answer from the biggest one to the second biggest one and then recurse that until you can't anymore, return that to the next order, and then just like have multiple recursive functions until you have 0?
Possibly. I totally admit, I am still kind of wrapping my head around this. I do think something along those lines is probably what's going to happen. In fact, if we have solution code here, I'm just going to take a quick look at this and see what an implementation looks like. So, right, this essentially gives us our ordered list of items. And if the number is greater than or equal to the value, then we have to figure out the number of times. Right, okay, I see. This is helpful, and this is kind of along the lines of what you were saying, Cody, of we're going through our ordered list here, and if the like number is greater than or equal to the value that we're looking at, then we need to figure out how many times there are. And to do that, we do this, what is this, floor division?
Yes.
Yeah, and then and then we're appending to our answer, number of times. And then we're taking the modulo to figure out what we have left to update it. So I am actually going to steal this code because I've gotten a little wrapped up in the parts that we're less interested in here. And in fact, I'll change this back to num. So there's a little more work I have to do here, right? I can't quite use this, but for, let's just say, numeral in ordered numerals. And so this is going to be if num is greater than or equal to, and the value is in fact what I'm calling numerals A, like the Arabic numeral. And in fact, what I'm going to do to make this even easier is numeral equals numerals sub A. Actually, that should probably be R, and then val equals numerals sub A. So now I can probably almost use this code. What's this thing? This is not a bad trick either, by the way, is basically to make like, if I'm like copying and using code or repasting it, sequence index is not an int slice. I'll figure out what that means when we run it. But this way I can
I
use this.
think it's just the name of the list, right? It's like ordered numerals instead of just numeral, maybe?
Oh, I was hoping, let's just change this to n to make life simpler so I don't even. It, I think numeral gets defined in multiple places. The reason being I'm iterating through the list so that this n is the name of each item in the list when I'm looking at it. Okay, so this now I think I've got my Roman numeral, I've got my value, I've got my number. If number is greater than the value times, and we use kind of the same logic here. So now I think the test is simply, let's see if this runs. So that one works. So that's a good start. I haven't added in the special cases. So I'll do that momentarily, but let's test if 3 works. And I do apologize that this took me so long. But I think we'll still have enough time to do a little bit of whatchamacallitsing, recursing. And in here, in fact, let's look at the README. I want the README over there and my code over here. And I want to look at my special cases. And let's go ahead and add these in. 4. And that's 4. And that's 9. And that's 9. And that's 14. And that's 14. And man, 44. That's 44. And then 944. And that is CMX. I think that is quite the special case. And that is 944. So now 1,000, 944, 500, 150, 44. So now hopefully, at least I've finally got into a working implementation that is passing most of these tests, and we have a little time to play with recursion. In hindsight, guys, I got a little excited about tackling this one. We should have just done the palindrome. But hopefully, if nothing else, kind of like seeing this workflow that I'm doing is useful. I know I'm using a lot of like keyboard shortcuts and stuff, but otherwise a lot of this is pretty, I think, applicable. Okay, awesome. So we now have a running program, which I really should have just grabbed from the solution branch to begin with, but say la vie. And half the battle is understanding the program, which was really the step that I needed to go over. And we've got this working, and now we do want to make this recursive. And Cody, I think you kind of had an interesting thought there. I was just wondering if maybe you could say that again.
Like to divide and conquer it so that you just recurse until let's say 1,000 does not go into your number anymore. You will return your value and then go down to the next recursive function, which will do the same thing for the next value. So like multiple basically a recursive function for each individual value, letter, numeral.
Right. Something along those lines, yes. I'm not totally sure off the top of my head here, but you know, I think you're on the right path, like looking for the repeated stuff. Like we've got this floor division right here. We've got like this update num to new val, you know, so, get rid of what we've translated already. So there's a lot of stuff that we can do here. We're gonna need like a base case and then a recursive case. And I think the question, I think you might be on the right track. I could use a little help, to be honest, is essentially
I
what
was
do we-
gonna say also you might need to like put answer in as an argument that equals an empty string in the function, so that way it'll carry that value onward. Because like once you recurse, won't answer reset to an empty string again.
No, if we call the recursive function, if answer is defined here in the global scope, it will kind of get like passed in as a closure. So short answer is no. Like what like I think we want to do really is right, like something like what is this? To Roman recursive. In fact, that should be, we'll just define it inside there just for simplicity's sake. And let me put a pass right there. And we basically need to turn this for loop into something like that. And I think I will put this stuff there just for simplicity so we can keep our names the same. So I think if we define answer out here, because it's in the global scope, we can continue to use it, but we'll see if that's the case or not. There may be some things we need to pass along. I'm not quite certain, to be honest. So with the base case, I think the first question is, how do we know when we're done? How do we know when we've converted 100% of the number into Roman numerals? Like with this current approach that's iterative, how do we know when we're done?
It's less than 5, or at least it gets into 1, 2, 3. Well, that's easy when there's no more numbers left, I guess.
Yeah. Does num, in fact, I wonder, does num end up becoming 0? I'm not 100%, but let's find out. So I'm not even worrying about this recursive thing right now. Let's run this let's just grab something from the test case. Perfect for this. So let's just go ahead and run this. and see what happens. To Roman 944. Okay, so that kind of makes sense to me that the number is going to be 0. As we do this, though I actually would have expected like this to be printed out more times, but let's just throw a couple in here just for sanity. How about, I don't know, 673? How about 1213?
Yeah, I think you hard coded 944. That's why I went to 0 immediately.
Oh, you are right, because that's an edge case. That was listed in the edge cases, I think. So you're right, that's not a good one to look at. So these other ones are much better ones to look at. So indeed, in both of these cases, num gets turned into 0, which makes sense because if we see what's going on here, each time we do a modulo, where does it happen? Yeah, we essentially do a modulo division, right? Like we're reducing num each time. So eventually it should become 0 because we're like dividing it by all the stuff that we've already turned into Roman numerals. Does that make sense to folks? And if not, please let me know, because I know I'm like glossing over that bit. Cool. So this feels like quite possibly a very good base case. We might need something a bit better, but I think that's a good start. So let's get rid of this pass. If num is 0, you know, Cody, you may be right. We may need to declare answer in here. And in fact, let me go ahead and grab this stuff and put it below the for loop, because I don't want to get confused, to be honest. So why don't we can't define it here because this is where it happens recursively. So let's pass it in as an argument. So when we call this, it's going to look something like this. And why are we not doing pass? Why did all my stuff get?
I think the return statement at the return answer above it.
Oh, that would, yeah, you're absolutely right. Thank you so much. We'll just do that, and then I'll worry about renaming or whatevering later. Thank you so much. Great call. So we're gonna call it, for the moment, we're gonna call it like this, like let's say 673. And like an empty string. And in fact, yeah, I think that's how we'll do it. It's a little weird. If you guys remember, we briefly looked at like reducing when we kind of looked at map filter reduce, and this is sort of the same idea. There's probably a more elegant way to do this, but as again, I'm sort of going for shortest path here as we're a little tight on time. But this lets me return answer. This gives me something to return, right? This at least gives us a sensible sounding base case. When we finally dealt with everything with our number, we return the answer that we've constructed. And so this seems ridiculously simple, but this is maybe the trickiest bit to figure out. And and I see it wants all this stuff. So in fact, what I will do, I will just copy this whole thing and paste it right. I'll just put it. Yeah, it doesn't need to be in there. We can put it outside of it for a closure. And this is not a great practice because it will create it like a zillion times, but that's okay. I think that well, actually, I'll put it there and we'll cross that bridge when we get there. And in fact, let's go ahead and have it look something like this. Let's pass in, let's say, our list of ordered numerals, the number, and the answer. Because we might be modifying all of these things. So now at least I've got something a bit more sensible. These, I haven't done anything with them yet, so we're gonna comment them out for the moment. So now, like, let's use a simple case of, I don't know. 5 as an example here. So we know what we want to do. We want to go through this from biggest to smallest. And we basically want to do this logic. Like, we want to check if it's greater than the value. We want to do this floor division. We want to add the answer there. We want to do this thing to update the nums. And we want to do that for all of them. And then when we're done, we want to return the answer. So I know that I'm going to want to use this logic here for something. So I'm going to put this stuff there. And remember, we don't need the else because this returns otherwise. And I think what I want to do is with this and with this, let's say order numerals 0 are, and same thing here, order numerals 0A. And again, there's probably a better way to do this. In the interest of time, I just want to get this there. And remember, what we want to do is start with the biggest and go through. So what I'm thinking is we grab the biggest, we do our thing, right? We are updating the answer here. We're updating the number here, but then we also need to update like ordered numerals. So I think, yeah, I apologize. I'm probably not going to get an implementation of this working. I think we're actually a little closer than it seems. But I'm not sure if we will get 100% of the way there. But we're actually getting closer than it seems. Because here's what we want to do. Get the biggest. See how many times it goes into num. Update answer accordingly. And then see what we have left to turn into Roman numerals, right? Because if we have 1,000, well, 1,000's right here, and we're done right off the bat, right? So I think we want to do all of this stuff, and then we check for our base case. So if I have this right, I'm not even gonna worry about the recursive case yet. Let's see if this works for one. Yeah, 5 is perfect. Let's see if this works for 5. And it sure would help to print something, wouldn't it? So unfortunately that didn't work for 5. I thought I was getting somewhere, but I may have missed something. Let's see where we went wrong. Oh, yeah,
It
what's up?
only asks for the 1,000, and then it stops there because it's still at the
Oh, because I never.
0.
Oh my God, thank you so much. You're totally right. So let's actually test for 1,000. There we go. Okay, so that our base case works, right? That it seems absurdly simple, but that's actually, and Clarice, thank you so much, because I totally would not have guessed that that was the issue. So this seems really simple, but actually, you know, I'm doing all this stuff here. I'm doing floor division. I'm doing this. I've been copying and pasting. It's really easy for me to make an error. So if nothing else, this confirms that this works. And in fact, what we can do is just for happiness, let's run this for 500. Because I've commented out everything above 500 now. And so that's not surprisingly that also works. So you guys might see where this is going now, because what have we done here? We've added the answer. We shrink the number. Now we need to get rid of, I want to get rid of this now that we've checked for it. And can someone maybe tell me in Python how to do that to like get rid of the first thing in a list? I can actually Google it too. And of course, lo and behold, pop may do
First
it.
slide of the day.
Yeah, that's so right. A Python list is not an array, but you can see how like these concepts stick around, and push and pop are common, like JavaScript has them with arrays too. So I'm just going to do a quick test here to make sure that this works. Because the other thing, like some operations don't necessarily modify the list. So that's perfect. That's not quite what I want, because that's the end of the list. I actually want to get rid of the first thing in the list. So let's see, the delete operator is another option that's giving me.
Adam, for
Yeah.
Python, if you put the index into the pop, like if you pop 0, it'll pop off the one at the index.
Oh, beautiful. Megan, thank you so much. Perfect. So let's go ahead and then do this. Get rid of the numeral we've already translated. So it's 6 of one and half a dozen of the other where we do this. And now in our recursive case, what we can do here is order numerals. I have to make sure I get this order right here. Num and answer. Num and answer. And there is a specific reason I didn't want to do this in here. Can anyone tell me why? And in
It
fact,
returns a value you popped off.
yeah. And in fact, I made that same mistake here on line 61 because I'm used to returning array functions. So this was a mistake because this will return the thing I popped off. That's not what I want. The pop operation, we were talking about modifying lists in place. Well, I'm used to things that like return a copy, like map and filter. Pop does not return a copy, it modifies the actual thing. So we don't actually want to do anything with it. So that is more what this should look like. And this may work. I am honestly not certain. Let's try 3 and see what happens. So that is promising. Let's try 673. So that is less promising, where I have a list index out of range. So that tells me that there is some sort of implementation error that I've got here. The fact that 3 worked is promising though, and like we should break for lunch, but like the way I would debug this is I would just start moving up with small numbers, like let's try 6. So that failed too, but 6 is a whole lot easier to try and debug. Oh no, 6 worked. Actually, I'm sorry, I'm so sorry. So 6 works, so that's great. So like 27. So that does not work at all, because unless I'm totally wrong, that is not what 27 should look like. So I didn't quite get there. I apologize. This was an ambitious one. Anthony, you kind of threw down the gauntlet and I went for it. But I think we're on the right path. I've screwed something up with my recursive logic. And the overall algorithm might need to be shifted, but if nothing else, hopefully it was useful to see kind of like how to come up with a base case and a recursive case. And this technique of kind of modifying the stuff that gets passed into the recursive call isn't uncommon. If I had to guess, it may be the special cases that I'm not doing stuff correctly with. I'll push this
I
code
think
up.
it's,
Oh yeah, please.
since it printed 14 and 13, maybe it just needed to do the equation multiple times. I don't know.
In your times, when you're declaring times equals, you're square rooting it, right? With the 2, oh no, sorry.
No, I think that's floor division. But that is a good point, because we've got 14 plus 10, which gives us 24 plus 3, which gives us 27, which is what I put in. So this is there's a logic error, because I think it should look like XXVII, but we're getting the right value.
I did a little modification on the where you have the num modulo. And if you do just num minus equals and then in parentheses value times times or val times times instead of the modulo, that should handle the edge cases.
Num minus value times like that.
Yeah.
Yeah, I'm just for clarity, for teaching purposes, I'm not doing minus equals. Otherwise, I think it's a great thing to use. And we probably should. Num equals num minus value times times. Yeah, let's do it. I may have screwed up using something with that modulo. Let's see how we do. So that actually, I'll implement it exactly the way you said it. Just in case I got something wrong. I think I'm still getting the same thing for 27. Are you getting something else, or is it possible you maybe made some other changes to the program?
I haven't quite finished my recursive one yet. That's on the previous one.
Got it. Oh, okay. Okay. Yeah, I think the issue here is not with that. I could be wrong. I think the issue here is not with that bit of the logic, but with it's got to be something around like, with the base case or recursive case or how
I
they're,
think it, oh,
oh,
I think
please.
it's still like maybe when it's getting rid of the number, because it should go into 10 twice, which would be XX, but it only does 10 once and then it gets rid of the 10. And then it goes and keeps going. Or maybe that's not it. Maybe I'm thinking about this wrong.
I think the
Oh yeah, you're
14
popping it off.
Well, we get to 14 before 10, and 14 does go into 23. And so that must be why it put it in there. If we kind of look through what's happening, right? Like if I put in 23, we're going to get rid of all these big numbers, 1000 through 44, right? Because they're just too big. And this floor division, I think, would get rid of it, right? Because it would come out to 0. But then 14 does go into 23 once. And in fact, like we could add some print statements, and I'm pretty sure that's, now that I'm seeing this, I'm pretty sure that's what we see happening. And in fact, I think I'll just throw in, let's print like ordered numerals sub-0 to see what that is. Let's print times. Let's print just an F string. Val is val. Answer is answer. And this will help us see. And then we should break for lunch because I know we're running long. But we are tantalizingly close. So this is times, and it stays 0, which is great for all these things. And then when we get to 14, it does become 1, which makes sense because of the way that I wrote this. I must have screwed something up in sort of moving the code around, because I think this was
Right.
correctly handled. Yeah, please, what's up?
Matt in the chat, I think he has the answer.
in your dictionary, 14 shouldn't be a case because it's already handled by 10 and 4.
Oh, okay. I copied that over from. Let me get on the main branch here. I copied that over. I think it was from the solution branch of special cases. I copied it from somewhere, which was my bad, which only goes to show the dangers of copying. That makes so much sense. Let's see if I'm curious if we can find. I don't even know at this point where I got it from, which is not uncommon with programming. I think you hit the nail on the head there. Let's see what we get. Lo and behold, we get 27. Nice. Thank you guys so much, Matt. Thank you. And thank you too for pointing out, I think it was Clarice that Matt had the answer there. Yeah, let's try 29. Good call. So that looks good. What else do we want to try? So I'm really excited. I didn't think we were going to get there, to be honest. This was a hefty one. Anthony, thank you for kind of like throwing the challenge out there, and everyone, thank you for being patient with me. As you can tell, I kind of needed to get up to speed on this problem again. And a lot of the times that's what takes the most time, honestly, is like just wrapping our heads around the problem. But hopefully this helped actually with seeing like recursion and base cases and stuff in action. And this kind of approach is a sort of functional style thing, which is kind of cool to see. Like you'll see it later, like with reduce and stuff, of where we probably could, to be honest, put these out here in the global scope. and I'm pretty sure Python would just pass them in and that would work. Other languages that are a bit stricter might not let us do that. And it is kind of nice to see stuff being passed in this way to kind of track it. And it does make it a little more explicit. So it's definitely not the worst thing. And as you can see, it took a while, but once we figured out like what is the base case, like when are we done? And like what is the process, like how do we want to change things for recursion, then stuff started to come together. I know we've ran a bit long, so let's break for lunch and I'll stick around for anyone who has questions for a bit. There's nothing really on the agenda for today, so it is just problem stuff. I do need to send out pairs because today is a pair programming day. And honestly, this recursion stuff is good stuff to pair on. Just so we have a time, why don't we say coming back from lunch at 1:30 Central, so in just over an hour. I'll release the pairs before then and get everything up before then. But, you know, just communicate with your pairing partner. And if you guys want to take a bit more time because we ran long for lunch, you know, that's totally fine. It's sort of, as long as you and your pairing partner are communicating, that's all I care about. And we'll do stand down at the normal time. How's that sound? Awesome. For those of you that need to retest, if you want to take a little bit of time to work on that today, go for it. Just coordinate with your pairing partner and try to get like a solid hour or two in first. If you feel like you really need to focus on retaking the assessment, maybe ping me if I should just reassign the pair person. But I would like everyone to spend like at least an hour working on this recursive stuff. And